as you can see, you can use Python and R for now, and for both of them you can either start with a notebook or with a script. Notebook is what I showed you. It's similar to a Jupyter notebook. For R2 you have R markdown. It's a notebook again, and you can use your normal scripts, basic lines of code that you can write. It's your preference, is just preference for now. I mean, later on you may decide what you should run as a notebook and what you should not run as a notebook and run as a script. For now, you can use it interchangeably. I would prefer use notebook for learning, and then later on you can go for normal Python scripts. Okay, so we'll start with the demo of the Python. There might be people who have not used Python before, so if there are questions, please ask. We'll try to be as explanatory as possible. You can write in the chat. Okay. So first of all, we'll begin as I showed you that the data is included when you start a Jupyter notebook. So it's basically stored in your Kaggle folder in input in Titanic. So you have that Windows Explorer wala feeling. You have your C drive, then you have your documents and everything. Here there's no C drive or D drive. Okay, someone wants to revise the previous session. Okay, we can do that. So what I'll do is, while providing the demo, I'll go through the points again so that it makes sense for everyone. So I won't do the entire thing right now. So as I go through the session, I'll keep on explaining the previous things again. So it could be like okay. So yeah. So the data, when you start a new Jupyter notebook, for the competition that you start, all the data is included in your Kaggle folder, in your input folder with the name of the competition. So this code block is the first code block. It's default when you start a notebook. This is already there. As soon as you run this block, they'll show you all the files that are in your runtime. For Jupyter notebook, welcome Kuljit. We have started with it. So yeah, so as I was saying, this is a Jupyter notebook, and this is the code block that you have in like default. And then in any code block that you ever want to run in a Jupyter notebook, you can press this blue button, and it will run it for you. You can run it all the time. I mean, you can run this code block and go back and run this code block. Be sure that your all the variables, they will be updated. It's not like if you run this block and then you run this block, if you updated the value here, it won't be affected here. No, it would be affected. So if I say I equals to 5 here, print I, 5 was printed. Now I have made it I equals to 6 here. Then print I again. So now the value of 6, it make keep it in your mind that if you have updated the value of I here, it will be updated here too. Okay, oops. Make it print. Yeah, so I had set the value of I 5 here and I printed it. It was 5. Then I made it 6. And when I printed, I have 6 here. Even if I print this block, even though it's before, like it's uh, chronologically before it, but then the value of I has updated. So it's a considered as a normal program, but then make sure you should understand the order of execution of the code blocks. Might be looking like you need to learn something new. Take my word, you will enjoy using Jupyter notebooks. When I first learned Jupyter notebooks, I started using it for all of my Python projects. Like it's very easy to use it for prototyping, for automation and everything. It makes it very simple. So if you want to run a code block, you can click on this blue button, and the other option is to keep pressing shift and press enter. So like you press Control A, you have to press shift enter, and it will run the code block for you. If you want to add a new code block, you'll hover on a specific code block. You'll get the option to add a code block. You can also add a markdown block. What's a markdown block? You can write your normal uh, alphabetical sentences here. So what I can do is here is I'll write here starting learning pandas. So when you finally complete this notebook and you save it, this also stays there, and the Python interpreter knows that it doesn't have to execute it. So if I write it in a code block, it will give me an error saying that it doesn't know what's static, it doesn't know what's learning, it doesn't know what this is. But then when I put it in a markdown block, it knows that it's meant to just give an idea about the code. It's just kind of like a comment, and this is very powerful. You can include images, you can include API calls, you can include a lot of stuff in it. So yeah, it's out of scope of the course to know what markdown can do, but then it can do a lot of stuff. Just Google Jupyter Notebook Markdown and you'll get all the info. Okay, so now everyone start learning pandas here. So what's pandas now? Pandas is a Python library. So it makes it easy for you again to process your data. It is a lot of commands and like APIs, application programming interfaces to work with your data. You can load data from various data sources into your pandas ka data frame. What's a data frame? Data frame is a table. It's a table in the sense I'll show that. I'll go through it to give an idea. So table is like your database table, and you can do all sorts of queries on it. But then it's in the runtime. You don't have to connect a MySQL database to it. It's in your runtime. So how do you get data into your table? There are various ways. You can just write some list and include it. You can also include JSON files. You can connect it to databases. You can connect it to Google BigQuery. I'm not sure. I guess I'm a bit confused here. You need to check if you can connect it to Google BigQuery. But then, yeah, you can connect it to a lot of different data sources. So what we are going to use here, the most common, which is most common, that's a comma separated file. So what's a comma separated file? So I'll just type the stuff how a CSV file looks like. So for example, consider it to be a file that has your names and roll numbers. So how a CSV file would look will be something of this sort. Okay. So this is a very simple way to store your data. So the first line is usually the headers, the name of your columns, and then you are including different attributes via commas. Like you separate you when the file processor processes it, it starts taking up alphabets MOHA. As soon as it sees a comma, now it knows that it has to enter 45 into the second column. This is how it stores the values in a comma separated file. Just comment it out. Yeah, so this is how a CSV file is stored. So pandas, you don't have to tell it anything about it. All you have to say is that please read this CSV file into a pandas data frame. I'll show you how to do it. So I'll import pandas first here. Import pandas. Okay. So one more good thing about Kaggle is when you use their Jupyter notebooks, they have all these libraries pre-installed. It's very rare to see that a Python library that you want to use and it's not included. It's very rare. So most of the cases, your libraries would be pre-installed, so you don't have to get into the hassle of installing your environment. As I said, libraries are usually pre-installed. So what I'm going to do is I'm going to write import pandas as pd. So I've imported the pandas library, and I've said whenever I want to use anything from this pandas library, I'll call it as pd. So just for flexibility and usability, I have replaced the word pandas by pd. So now I can access pandas specific commands from it. So the first thing that I would like to do is I would like to read the CSV file. So as I said, Kaggle has included all the stuff from all the data files directly into it. So we'll just quickly load it, give the path. So yeah, read CSV tells you read CSV you can use to read a CSV file to a data frame. All you have to include is the path of the file. So we give it the path. Okay, we're loading the train.csv file. So as you can see, it has nicely printed the all the values from the CSV file. What I'll do is I'll assign this to a variable so that I can now it's just taking the command and giving you the output. It's not storing this anywhere. We would want to store it so that we can do our analytic stuff on it. So I'll assign it to a variable. It's basically train. Let's do this. I call the read CSV command from the pandas library on this path, and now I have all the entire table stored in the variable. What I'll do is I'll do train dot head. This is another function that I'm calling. So pandas, what actually happened when you assign this to it is pd.readCSV created an object. If you remember object-oriented programming, it created an object of the type data frame and stored it into train. So now we can call the attributes and functions on this object. So I have train, I call train.head. So what dot head does it displays the first five elements. So to get a quick view on your data to see if it's loaded properly, if it has loaded all the headers and everything. So you just call train dot head and it will give you all the important, it will display the data nicely for you. Okay. So what I'm going to do is next step is I'll write 8 here and I'll press shift enter again. Again, I press shift enter as you press control A to print to run a specific code. So now when I press train.head 8, I saw 8 variables. So now I want to see 10 variables. You can keep doing it and it will keep on giving you the values. Very handy command. The other command is train.describe. Okay. So what is this now? So when you had loaded your data, it has various types of uh, various columns into it, and the rows and columns laid down very nicely. Now what dot describe does it gives you basic information about each numerical column. So if you can see, it has ignored the name column. The name is here, but then you can't see name here. So it will remove all the non-numerical values. It will take only the numerical values, and it will give you basic idea about your data. That's basically the count. The count is basically the number of not null values in a specific column, then the mean, the standard deviation, the minimum value. It will also give you the 25th quartile, 50% of quartile, 75 quartile, 75% quartile, and the max value. It's very handy to get a quick overview. There are various other commands that I would like to show. So there is this thing, yes. So this gives you the data types of all the columns available in your data frame. So again, this is the data frame. This is how internally Panda stores your data. This is how you see how Panda stores internally the data. So it has these rows and columns. So these are the data types for each of the column that you include. The passenger ID is an integer, survived is integer, P class is integer, name is an object. I believe it should be an object of type string. Again, this is object oriented, so it's an object of type string. All of these stuff is stored as data types. So yeah, what else? So one more important thing is when Panda stores your data, it assigns these rows, columns, and as well as these rows. So these are not runtime indices; they are actual labels. So you can access this particular row, you can access this particular column. Sorry. So these are the labels, as I said. So how do we access a specific column from this data frame? First, I'll quickly print this data frame again here so that I can check it. So yeah, what I'll do is I'll just print the survived column. That's the final output that we want to predict. So I'll just print it. How do you print it? We like train square brackets as you index an array. Press shift enter. So yeah, see it has just printed the all the survived values. These are the values, and on the left, what you see is basically the labels of the rows. Okay. So what I'll do is I'll type it using the print command. So it is also showing us some extra things like what's the name of the column, how many not null values do you have, and the data type of the column. Okay. One thing, now there are various other ways to index through a pandas data frame. I'll start with train.iloc. Okay, we see that it's square brackets, and what I'll do is I'll just go through the first 100 rows, and I'll go through the first three columns. Okay, so it has loaded the first 100 rows. Obviously, it can't display everything because it's not feasible to do that. So it will just show you. I mean, yeah, I should not take all of them. I should like take a reasonable number. That's five. Yeah, five rows, two columns. So it has taken the first two columns from here, the passenger ID and the survive. So this is train.iloc. The other indexing type is train.loc. Again, square brackets. These are not functions. These are way of indexing. 100 and then survive. Okay. So again, you have the survived column and the first five rows of the survived column. So it looks pretty same. Like you can do the same things with these two. So what is the difference? Why do you have ILOC and LOC? So the difference here is LOC gets rows as columns with the particular labels from the index. So LOC uses the labels and ILOC uses indexes. So I've written it's more easy to show that in terms of columns because the column names you have alphabetic values. So if you would want to access them by names like passenger ID, survived, P class, you'll need to use .loc so that you're telling it that I want passenger ID, I want survive. But if you want like the second column or the fourth column, you will have to use train.iloc. This is a major difference because pandas not just indexes your data, it also stores them as labels. So if you want to access it via labels, use ILOC. Sorry, if you want to access it by labels, use LOC. And if you want to index it, so if you want to access from the second column to the fourth column for the second row to the third row, you will have to use ILOC. It's a bit confusing, but you can always Google to see what's the difference between ILOC and LOC, and you can use whatever you want whenever feasible. So this was a basic idea of pandas. If you need any other information as to what a specific command does or what else can you do, you can always type help and then you can type the value and it will give you a nice looking output showing what are the parameters that you can access, how you can access, how is the data frame, like all. It's basically like a complete Wikipedia on pandas, on the pandas data frame. There are other stuff in pandas too. So now, yes, I'll take a couple of questions if you have for 2 minutes. You can add questions into the chat box, and then we'll do the data cleaning, the demo of the data cleaning. Put in the chat box if you have any questions. Okay, there are no questions. So yeah. So this is what we had done in the previous session. We had seen ways to data clean. Now what we'll do is we'll do attempt to do these all of these by using pandas. A small demo. So we have the entire file in train. Okay. So as I said, there are some unwanted columns that you want to get rid of. Right now, it should be passenger ID. Like quickly by seeing, you can say passenger ID is the ID, and we are not using it because it's from the database, so we don't need it. See, it's starting from one and stuff like that. These are the names. We don't need all of these, so we'll just get rid of it. So how do you do that? Just train drop and you just type send in a list of the values that you want to get rid of. Okay, so why did we get a key error when we properly put all the names? We didn't do any mistake. So when you type the drop command on pandas, uh, it thinks that you want to remove something from the rows. As I said, these are all labels. These are not just indexes. So you can remove the second and the third row by putting 2 and 3 here. So what it is thinking is that you are providing it the row k values. You want to make sure that you are providing the column labels. So for that, what you have to do is you have to tell them that I'm using the axis one. See, it properly remove them. So what is this axis now? So if you want to do the row indexing, if you want to remove anything from the row, that's row major. It's stored as row major. So anything you want to do on the rows, that's axis equals to 0. If you want to do anything on the columns, that is axis equals to 1. I mean, in the entire pandas system, if you anytime put axis equals to 0, it will go for the rows. If you put axis equals to 1, it will go for the columns. That's just a way to tell him what are the rows or what is the label that you want to remove. Because I can make the labels of the rows as alphabetic values. So it's not necessary that if I put alphabets that it will work on columns. It can work on rows. Okay. So yeah, we have this small. It looks better, isn't it? Yeah, I've removed the unwanted stuff. I've removed the unwanted columns. Now comes next. According to this, I have to handle null values. How do I handle them? I can drop the columns, I can drop the rows, I can impute values. We'll try them all. So first I'll see which of these columns have a lot of null values. So it's a small trick to count the number of not null values. So yeah, so a small thing. It's 891 rows. We have 891 different training examples spanned across 10 columns. And one more important thing, I've done a small drop command on the data frame. If I try printing the data frame again, see there's no changes. And why? What happened? Where did this go? So when you apply a function, it's not in place per se. So we have to tell it to assign it to train. Now it will do the changes and assign it to the train variable. Now when I run it and then I print it, the changes actually happen. Okay. So what I'll do is I'll try printing the number of null values in each of these columns. Okay, so what it says is there are no null values. So what is happening in this small print statement is I'm taking the length of the survived column from the train data frame. This is a Python command. So it counts all the rows, all the rows basically. So it basically comes down to 891 here because there are 891 rows. And then I subtract from it that dot count. What dot count does it? It doesn't count the null values. So when you subtract the null values from the total count, you actually get the not null values. So there are 0 not null survived. We'll do the same for all the columns to check performance. We have 10 columns, so we'll do all of them. So we have just 10 more minutes for this meeting to end. And we started. Very little is left. We just have to work on the null values. This is the most important. Okay. Okay. So now we know how many null values do we have in each of the columns. So as we can see, we have 687 null values in the cabin, which is something that we wouldn't want to use in our analytics. Then we have 177 in our age, and there are just two in the embark. So according to this, there are three ways to handle null values. You can drop the columns, you can drop the rows, you can impute the values. So we'll start with dropping the columns. So it doesn't make sense for you imputing 687 null values. It just won't make sense because there are so many nulls and you are providing it extra information. You don't want the analytical model to predict on the basis of random values or some statistic. So we would just remove the cabin. So we'll move brain, just brain, we provide it the cabin. We have to also make it. Okay. So now when we print it, we don't have the cabin thing because we don't need it. Next is age, that's 177. But age is something that would be very useful in deciding if a person would survive sync. So we might want to impute the values. So out of we can impute 177 values out of 891. So how will we impute them? We can use any of the statistics, mean, median, mode, whatever we want to do. So it's very handy to do that using pandas. So what I'll do now is quickly impute that part. I'll use this place only so that it stays on a single screen. Ping dot and I want it to age. Okay. So what I'm saying is take the age column from the train data frame and fill all the null values from it. And I want to give it the value with which I want to fill it. So I'll tell it to use the mean of the column. Again, I'm saying take the telling it to take the age column from the train data frame and I'm calling dot mean over it. What dot mean does it takes the average without the null values. So it will take an average of that entire thing and then I'm telling k train fill all the train age null values with the mean of the same column. So when I do this, there are all 891. If I call dot count on it, that's basically checking the number of null values. There are no null values because all the 891 are not null. It will become a bit clear. So again, it is not in place, so we have to assign it. We'll assign it to the correct column. Okay. So I said assign the this fill null values column, replace it with the new one, basically the same column. Okay. Now when I count the null values for age, this was the thing. I do this here. there are zero null values compared to 177 here. This is a handy way to do it. There will be better and faster ways, but then this is easier to understand. And you can, one more thing, you can always chain values. So I've written train age here. That's a command. Then on that I'm calling fill now. On train age I'm calling fill null, and within it I'm passing train age dot mean. So do one more thing. We'll just print what's the output of train age dot mean. See, so the mean age of the people on board the Titanic ship is 29.69, and all the null values I'm replacing it with the mean. That's 29.69. So this was way. Now the embarked way, it has two null values. What I'll how I'll handle it is a bit different. Uh, so there are only two null values, and it's a categorical variable. By categorical variable, I mean these are S C S S S, and these mean something according to this. All these stuff means something. So taking the mean, median, mode wouldn't make sense. So what I'll do now is I'll want to check what's the count of each of these categorical variables. Take the and I'll count. Okay. So, so now we know that there are 889 values. There are two null values. What we'll do is very quickly, as we don't have a lot of time. We have just 3 minutes until this meeting ends. So we'll do a cheat right now. We'll fill all the values with this S category, just to make it quick. So what I'll do is I'll fill all the null values. Yes. I'll show exactly why I chose S in a while in the next meeting. So yeah, just putting S here and yeah. Oops. Luckily there will no. Okay. So here we end how to handle null values. There are two ways that we have shown, three ways. We have dropped the entire columns and we have filled the null values. Basically, we have imputed the null values. We could have also dropped these values, but then we didn't do it right now. We can do it some other time. We have lots of other time when we're processing data for creating machine learning models. We'll try all of these values, but then this is a way, and all the other ways to impute goes to same are similar. So we have precisely 1 minute 30 seconds. If you guys have any questions, put it in the chat. I just need 10 more minutes for showing a final thing, and we'll do it in the next meeting. Just 10 more minutes. Till then, for the next 2 minutes, you can ask any questions that you have. Put it in the chat panel. Sorry, Atharva, you told me to explain this line of code again. Can you tell me which line of code? I didn't see it at that time. Atharva, can you tell me which line and explain it? Okay, where I found the number of null values. Okay, I have less than a 1 minute. If this meeting ends, I'll do it in the next meeting. We'll start it quickly. We won't take a break. So yeah, so basically you mean this line. Okay, I'm just copying for age. Okay, first what we'll do is we'll break it down. So yeah, length is a Python wave function to count the number of count the number of indexes basically in the pandas data frame. When you call length on a pandas data frame per column, it counts all the values. It doesn't care if it's null or not null. It just sees that there's a row in this column. Just take counts null as well as not null values. So it will give me the output. This thing over here, train.count, right now it will give you the same output, but this counts only the not null values. So we'll get the null, all the values from here, and then we'll get the not null values from here. Then we subtract them. Okay? Once we subtract them, we'll get the number of null values. But then, as you can see here, we are concatenating strings, so we need to convert it to a string. So we are typecasting it here. Okay. So we are typecasting it here. Again, it's 0 right now because I filled the null values with s. So if I would have filled it, we'll get a 2 here, and then I'm just add concatenating this string age equals to, and then here to display it nicely. This was the command. I hope it's clear. If it's not clear, you can just again. Okay. Yeah. So one more thing, why did I use S here to fill the null values in embarked? So I'll show something quickly. So when I take pane of embarked here, I'll do now this in embarked dot. Okay. So what this thing value count, what this function does, it gives you the number of occurrences of each categorical variable. Each category, it is giving me the number of occurrences. It says S is 646, it would be 644 before I assigned it. Then C is 168 and Q is 77. As I said, you can impute the values with the most occurring value, so I imputed it with S. So this is a handy function to display all the like the count of each category. Coming to the next part, which is basically handle categorical variables, as our machine learning model cannot analyze alphabets and strings. We need to convert it to numbers. So what we would do is basically uh, first we'll call the check the data types of each of the variable now. Okay. So we see that sex is still object and ticket is still object and embarked is object. So we need to handle them and convert it to numericals. Either it's int or float, doesn't matter, but we have to convert sex, ticket, and embark to non-category. That's basically numericals. Int or float doesn't matter. So what we'll do now is first we would want to know what are the different categories of uh, sex or ticket or embarked available. So what I'll do is I'll do this. Okay. So now it says you can. They have given two inputs as female and male. So what is this magic function again that gives us this quick answer? So this is another Python data structure, which is basically a set. Python data structure set. It includes only non-repeating values. So you can give it any array or list or tuple or list of strings. It will give you all the non-repeating values. It will give you a set, a mathematical set. So there might be many males and females, but it's telling me that only males or females are allowed. So the next step to convert this categorical values into numericals is we'll create a data dictionary again. So we create a sex dictionary. What we are saying here is female is equivalent to a 0 and male is equivalent to a 1 in our data dictionary. So what we intend to do is we want to replace all female words from the column to 0 and male words to 1. So again, what is this dictionary? Now it's another Python data structure. It's indexed based, so you can assign keys and values. So I'm saying when female is the key, 0 is the value. So I've created a data dictionary. Now I have to instruct pandas to replace all the females with 0 and males with 1 in the actual data frame. So how do I do that? So I'll run this. And what I'll do is I'll take train and then I'll call map over it. So as you can see, all the values from this column have been replaced by numbers. So this was the initial column, and this is the changed column. Again, it's not in place, so I need to assign it. I need to assign the original column from the data frame with this new column. So I'll take this here and just assign. Okay, now if I see here, you can see it's all numbers. Now when I call train.dtypes, again, now sex is an integer. It's not an string. When one column we have already handled, there are two more to handle. Another column is embarked, which is again a string object. We need to replace it. Will follow the same thing. So create a set out of it first to know what are the different values. Okay. Then we'll create a data dictionary out of it. So we want to replace C with a 0, Q with a 1, and S with a 2. Create a data dictionary. All we have to do now is map it. Pass in the dictionary to the map function for it to map it. Okay. See, now everything is replaced. Again, it's not in place, so we need to assign. This is very important. Assigned it. Now when we see train, all the embarked have been changed to numbers, and everything else is numerical apart from ticket. So when we see the ticket column, it's pretty difficult to parse it. So for now, we won't be doing it. Later on, we'll have time to properly try to parse it nicely, because we have ticket ke values for all the training examples. So it could provide some nice impact. But then, as you can see, it's a mix of numbers and categories. So first, have to decide if it's useful, if the ticket makes any sense. Once you have done that, we'll have to parse it using regular expressions, or maybe string indexing. But then it's pretty out of scope right now, because this parsing the ticket column itself will take half an hour or something, 30-40 minutes. So we'll not do that. So what we will do is we'll just drop it. Again, we have to give it the access. Okay, it has been dropped. Now we need sign it. Now we have the data frame which has all these values with us. So this we could call the final clean data. Say we have to do data engineering, model training, and a lot of other things. We are here right now. We have to do the end uh, EDA. That's basically creating charts and all to get an idea of what the data is. Then feature engineering is creating more columns out of these columns, training models, and then deploying it. I guess we'll end the content for now. Next 3 hours, I guess, should be enough. So if you guys have any questions, you can write it in the chat or put it on the WhatsApp group. And yeah, we'll open the code. You can ask any questions in the chat. Wait for 5 minutes, I guess. Then we'll end the session. Okay, one more thing. All the work that we have done on Kaggle, you can actually like save it. So if you can see, there's this thing called save version. I can click on it and tell it to save it as a HTML file. So basically, this version actually saves it directly, and save and run all actually runs all the code docs and saves it. So what I'll do is I'll just click save and run all so that I can share the file with you later on. It's saving. I'll share a link to it later. What does actual access actually do? Okay, so consider this as a matrix. So a matrix is something of this sort. 1, 2, 3, 4. Okay. Then you'll have a comma here, then you'll have something like 6 comma 8, 7 comma 3, comma 2, 8, and so on. So this is basically a matrix, the mathematical matrix that you use. So these are the columns, and these are the rows. 1, 6, 2, 7, 3, 4, and 4, 2 are the columns, and 1, 2, 3, 4, and 6, 7, 3, 2 are the rows. Very similar to what is here. So when I say that Pandas stores the rows and columns with labels, so this is a label for this row. This is a label for this row. This is the label for this row. Now, when I call any functions like drop the specific label, so it won't know if it has to drop a row or a drop a column. So yeah, so I want to drop this row, so I'll just say train dot drop 2, and how will it know if it has to drop a row or it has to drop a column, because drop is the same function for dropping rows as well as columns. So there's this other concept called as storing matrices. So any matrix, your computer memory, it stores it in a linear fashion. So basically it stores these values, then these values, then these values, then these values in a single row. So for the computer, it stores it in this way. So, oops. Okay. So it knows that all these values are available in this manner, but then it has to make sure that it has stored it in this way: 0, 3, that one, then this. It has not stored it in this manner: 0, 1, 1, 0, 0. So when it stores it 0 after 3, after 1, after 22, after 1, 0, this is called a row measure format. So first it's storing row wise, row wise, row wise, row wise. So it will consider 0, then 1, 2, and 3. This is the row way. Then it will consider the columns: survived, P class, sex, age, siblings, parts, whatever. So this is a row measure format, and Pandas considers row measure format for naming the axis. So if you want to do anything in the rows, like if you want to remove 0, 1, 2, like this entire row, as it is using row measure, so this is the axis 0. So when you want to remove a row, you name axis equals to 0 so that it knows that it has to remove a row. When you tell it to remove a column, you put axis equals to 1. That's the second, like, is second on the line basically. So now it knows that it has to remove a column. So when we wanted to remove a particular row, a particular column, we set it that axis equals to 1. So it knows that it has to remove a particular column. If we don't say anything, it defaults to axis equals to 0 because it's row major and rows have more priority, and it tries to remove, it tries to search ticket here in this part, but it won't find that because it doesn't exist. So it will give you an error. If I do it this way, ticket, and I'll press that, I'll get a key error because there's no ticket here. Okay, or yeah, this is how pandas indexing works. Okay, you're welcome. Thanks for asking. Any other questions? Please do ask. We'll wait for 2, 3, 5 minutes more, then we'll wind up. If you have any questions, you can ask on the WhatsApp group too. I'm checking that too. If you are not able to find the chat window or something, I know it's not very easy to find that, so you can just put it on the WhatsApp group if you want to. Okay, one more thing. So if you guys want to practice, I'll share this notebook to share the code. But then if you want to practice these parts, the creating the problem definition and then writing down the requirements, designing the output, and searching the data. Mainly these three parts is something that you won't get a lot of practice online. Like the courses are more geared towards machine learning, and also these things are usually not covered. So what I would suggest is go to any website or anything, like go search the internet. If you find any data or any topic that you are interested, try creating problem definitions and requirements for it yourselves. Create the couple of requirements, create the problem definition, and I would suggest this, do this and share it on the group. I can have a look on it, and if there's anything I can suggest, I'll do it. For data cleaning part, I would suggest you to go to Kaggle, find a good data set, and practice all these things. If you find any issues or if you find any other questions, how to do any specific task, you can ask on the WhatsApp group later on. I'll highly suggest doing this before the next session so that like fits in the mind nicely. And we'll have the next session probably in the next week. This week is a bit calendars are pretty full this week. We've been busy, so we'll do the next session in the next week. We'll try to find up the. So I guess thanks for joining. We'll end it now. And yeah, you can do these things: create a problem definition, write requirements, and create a design, and practice on online data sets. It's highly recommend that you do a couple of these before we'll go for the next session. You can ask on the WhatsApp group always. Thank you.